This is lesson 11.2 and 11.4 combined, and it will be surface area and volume of right prisms and cylinders. So first of all, the definition of a prism. A prism is a polyhedron. That means it's a three-dimensional shape and all of the faces are polygons. It has to have two parallel faces, and those parallel faces are called bases. And the bases are also congruent. So it has two parallel and congruent bases. The other faces are called lateral faces. And in a right prism, the lateral faces will be rectangles. Okay, so you see that we have an example of a right rectangular prism here. The altitude or height of the prism is how tall it is. Okay, so the altitude or height has to be the perpendicular distance between the bases. So on this one, it would be this distance right here between the top base and the bottom base. Okay, that's the perpendicular distance between the bases. And you've heard the term altitude before, which is the same thing as saying height. Okay, this is another example of a prism. So the first one, that's a rectangular prism because the bases are rectangles. So for this prism, you can see that it's sitting on its bases. With a rectangular prism, it doesn't actually matter which two faces that are opposite that you consider to be the bases. For this one, we'll go ahead and consider the red ones to be the bases, and then the blue ones are the lateral faces. So the top and the bottom is kind of how you normally think of as the bases, but a prism does not have to be sitting on its bases. So you need to be careful because, again, bases have to be congruent parallel faces. Okay, bases are parallel and congruent. Super important to remember that. Okay, so on this picture, you have the lateral faces, or the rectangles that are kind of going around the sides. Lateral means sides, like your lats on your body. And then the bases are the parallel and congruent. Okay, this one is a pentagonal prism because it's made up of pentagons on its bases. So for this one, those are your bases here. Again, because they'll be parallel and congruent, and then the other faces are rectangles. So this one is, you say that pentagonal. I know it kind of looks like pentagonal. You actually say pentagonal or hexagonal, okay? But a prism is named by the shape of its bases. Okay, so in this diagram, you can assume that when you're looking at these, that these are right prisms. So what kind of figure is each base? Well, this time it's a hexagon. And then the mathematical name of the prism would be hexagonal prism, because again, it's named by its bases. What kind of figure is each lateral face? Those are all rectangles. Okay, that's always going to be the case in a right prism. Name a segment whose length is the height of the prism. So the height is the perpendicular distance between the bases. Any of these vertical segments here would be considered the height. So I'm just going to say segment FL, but there's a lot of different options there. For a lateral edge, okay, so a lateral edge means, if we look back up here, a lateral edge is kind of the corners in a sense where two lateral faces come together. And then a base edge will be an edge where a lateral face and a base intersect. So down here, give a red color. So down here, one of those sides, that would be a base edge. Okay, but so would this one or that one or any of these are base edges. Okay, a lateral edge are the ones where two lateral faces come together. Those are lateral edges. So a lateral edge would actually be the same as the height on these. So segment CI is a lateral edge, for example. And then a base edge would be like KJ. So any of the sides of the polygon that makes up the base, that's a base edge. Okay, so here are some formulas. For our formulas, we'll use capital B represents the base area. Okay, the area of one of the bases. B means base area. P stands for perimeter of the base. P is perimeter of the base. And H is the height of the prism. Okay, so capital B is base area, capital P is perimeter of the base, and H is the height of the prism. Now, lateral area. Lateral area is when you add up all of the lateral faces of the prism. Okay, that's lateral area. And we find lateral area by doing taking the perimeter of the base and multiplying it by the height of the prism. So perimeter times height. Okay, lateral area is perimeter times height. So if you think about doing the perimeter of this entire base and then multiplying it by how high it is, you have just found the area of all of those rectangles that are the lateral faces all at once. The lateral area is when you add up all of these lateral faces here all the way around, not including the top and the bottom. Well, I shouldn't really say top and bottom. I should really say the two bases because it's not always necessarily sitting on its bases. Okay, but lateral area is going to be find the perimeter of the base multiplied by the height because they're all rectangles. So base times height, 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 all the way around. Okay, surface area means find that lateral area and add on the two bases. That's a total surface area. Sometimes you'll see capital T, capital A to mean total area. Okay, the sum of the area of all of its bases is just simply the lateral area plus, which we found up there, and then two congruent base areas. So surface area will be the lateral area plus 2 capital B. Remember, B was the base area of one of the bases. Okay, so total surface area will be lateral area plus 2 base areas. Okay, volume of a prism, we're just kind of filling up the inside of the shape. This should say the number of 1 by 1, this mistake here, 1 by 1 by 1 cubic units that fill up the interior. Okay, so little tiny cubes. If you think about little sugar cubes, how many of those it would take to fill up the interior of the prism. So the volume of a prism is calculated by finding the area of one of the bases and then multiplying by the height of the prism. Okay, so that'll be capital B times little h. Volume, area of the base times the height. So basically, if you find the area of this base of the prism and then you stretch it up, kind of think about grabbing that polygon on the bottom and just pulling it up however high that prism is. As you stretch it up, you're filling up the interior and you stop once you get up to the top. Or the bases are supposed to be congruent, so that should fill up the entire interior of the prism. Okay, example. Complete. HPB la sa vie is how we'll say that sometimes, okay? HPB la sa vie. That means we're looking for the height, perimeter of the base, area of the base, lateral area, surface area, volume. Okay, so when you're looking at these prisms, the first thing you want to pay attention to is the fact that the bases are congruent and parallel. The bases are congruent and parallel. So that means that we're going to have the pentagons here being our bases. So the bases are pentagons. Height. Height means the height of the prism. Okay, the height of the prism is 5 inches. It's how far it is between the two bases. And again, the bases are the congruent and parallel faces. These pentagons are regular. Okay, so when we go to figure out the area of the pentagon, we're going to be allowed to assume that that's a regular polygon. Okay, perimeter of the base, it's regular. So the perimeter would just be simply 4.5, 4.5 on one side multiplied by 5 sides. So that's 22.5 inches. Okay, let's figure out the base area. All right, so we have a regular pentagon here. I'm going to be thinking about this little apothem triangle on the inside here. So if I draw in that triangle, usually I'll draw it on the bottom, but I just decided to draw on the top this time, so I already had that top kind of traced out. So on that little triangle, that would make, because that's a 4.5 side there, that would make this 2.25. Okay, let's figure out the central angle measure. So if we do 360 divided by 5, that's 72. Cut that in half, that's 36 degrees. So that little tiny angle in there is 36 degrees. That angle right there is 36 degrees. Okay, we need the apothem to be able to do 1/2 apothem perimeter. So I'm going to figure out what that apothem length is. And remember, this will be trigonometry because it's not a special right triangle. All right, so we're going to do the, let's see, that'd be opposite over adjacent. Tangent of 36 is opposite, which is 2.25, divided by the adjacent, which is our apothem. Okay, multiply by a, divide both sides by tangent 36. We're doing 2.25 divided by tangent 36. And that gives us approximately 3.1 inches. Okay, now the perimeter of our base was 22.5. We're going to be doing 1/2 apothem perimeter to find our base because it's a regular pentagon. So 1/2, the apothem we just found was 3.1. Our perimeter was 22.5. We'll go ahead and multiply that out. 34.9, this is an area, so it would be in inches squared. Okay, we're ready to do lateral area, surface area, and volume. So lateral area will be perimeter times height. Perimeter of the base multiplied by the height. So the perimeter we already found was 22.5. And then remember the height was the height of the whole prism. So the height is your 5 inches there. We found it, we labeled it there already, so hopefully you remember that. Okay, and that's 112.5 inches squared. All right, total surface area. Total surface area is just the lateral area plus the two base areas. So from the previous step there, 112.5, we're going to add on two base areas. We already know the base area. One base is 34.9, so that means we need two 34.9s. Okay, multiply by 2, add 112.5, 182.3 inches squared. And then lastly, volume. You find volume by doing base area multiplied by the height of the prism. So the base area, again, we already knew was 34.9. We're multiplying by the height, which is 5. So 174.5 inches cubed. The next prism, what are the bases? Okay, so again, remember, bases have to be congruent and parallel. So that means that this one is also not sitting on its bases. The bases are the trapezoids. Okay, what is H? Now remember that H is the height of the prism. And that means the distance, the perpendicular distance between the bases. And then this is not sitting on its bases, which means the height is actually 4 centimeters, because if you were to turn it so that it were sitting on its bases, then the height would be how tall it is, which is 4 centimeters. Okay, perimeter. Well, this is a 3 root 5. We're going to use 3 root 5 for that leg also. This is actually an isosceles trapezoid. I probably should have said isosceles up here. Okay, so perimeter, and we know this is 6. It would be 6 plus 12 plus 3 root 5 plus 3 root 5. So 18 plus 6 root 5, and that's a length, so that would be in centimeters. 18 plus 6 root 5 centimeters. Now, the base area, that's a trapezoid. If you remember the formula for area of a trapezoid, it's 1/2 the height of the trapezoid. This can be a little bit confusing because we're not talking about the height of the prism. It's the height of the trapezoid times the sum of the trapezoid's bases. Okay, so 1/2. What is the height of the trapezoid? Well, that's 6. Okay, that's the height of the trapezoid. Okay, so 1/2 times the height of the trapezoid is 6. The bases are 6 and 12. So that's 3 times 18, or 54 centimeters squared. Again, this is an area, so square centimeters. Okay, LA. LA means lateral area. Lateral area you find by doing the perimeter of the base multiplied by the height. The perimeter of our base was 18 plus 6 root 5 centimeters. And then the height of our prism was 4. So distribute that, that would be 72 plus 24 root 5. And that's in square centimeters. Surface area. Lateral area plus 2 bases. So the lateral area is 72 plus 24 root 5. Okay, we have to add on 2 base areas. The bases were 54, so that'll be 2 54s. So that's 108. We add that on to the 72. We'll have 180 plus 24 root 5, and that would be, again, in square centimeters. Okay, and then lastly, volume. volume is base area multiplied by height, which would be 54 was our base area, 4 was our height. That's 216 centimeters cubed. Okay, this is the end of the part of the lesson on just prisms. I'm going to start a new video that will address cylinders.